All right, 5:30. Let's make a start. Cool. So the topic for today will be transformations. So we'll be covering the intro to transformations, which is basically 7A through C when it comes to the Cambridge book. We'll be looking at what are essentially the fundamentals in there. So let's take a look.
Wait, so are we doing unit one and two or three and four?
It applies to both, but this is the Unit 1 and 2 book that we'll be
Oh,
doing questions from. Yeah,
okay. Because I'm doing three and four.
that's fine. It'll still be applicable. You'll still
Oh,
be
yeah.
doing transformation stuff in 3 and 4.
Yeah, fair. Okay.
Yeah, just because it's in Unit 1 or 2, Unit 3 and 4, um, Unit 3 and 4 only has new stuff. It doesn't forget old stuff.
Yeah, fair. I don't have the unit one and two ones, so yeah.
That is fine. Yes, so if you have a look at the Word document that I put in the chat, you'll be able to download the book from the Google Drive link in there.
Oh, yeah, yeah. Thank you.
Yep. But okay, transformation fundamentals. So the way I'm specifically going to teach this one is the way that the textbook teaches it, because I found that across the board, people tend to find that approach a lot more effective. It's not the only way to do it, so if you already know a different way of doing things, then by all means go ahead and do that one instead. But what we're going to be doing is looking at the so-called point form version of the transformation. Basically imagining all the points along a graph as shiftable or movable. We follow these 3 steps when it comes to applying any sort of transformation. Let's have a look at what that looks like. First kind of transformation is a dilation. This is where you're stretching the graph, either along the x-axis or along the y-axis. You'll find that the book typically uses the words from the axis, which you can basically think of as the opposite direction to what's been listed. The reason why is because if I draw like a quick diagram of what that might look like on the handwritten section, if I imagine just having some sort of point, then dilating along the y-axis would mean stretching in the y direction. It's going along the y-axis. But an alternative way to imagine that is that it's going away from the x-axis. It's going away from it. The book will typically say from the axis. So when it comes across and you see that, just be aware that it's pointing in the y direction. The way you handle that is with a multiplication on the y variable. So if you go back to the screen share, you'll notice that the multiplication applies on the y because it's the y values that are changing. Now, following the actual framework. First things first, identify what that transformation is. You always start at xy and you always end at x dash y dash. The thing we want to know is, what is our x dash y dash? In this case, x dash stays as x because nothing is changing. Y dash is going to get a times y, where a is whatever your dilation factor is. From there, rearrange to get in terms of x and y. So literally just get them back on its own. And then substitute that into your function, whatever that is. In this case, we have just some sort of generic y equals f of x. When you substitute, it just means replace y, so this thing, with this. That's why you get y of a here. And that means replace x with x dash. Now you notice I've dropped dashes on this. You drop the dashes because those are mainly there for us, rather than because it's mathematically required to be there. And so fundamentally, the final result there is whenever you do a dilate along the y or from the x, it's the same thing as just multiplying your function by that value. This is a bit heavyweight for doing individual transformations. It'll become more effective as you have to do multiple in a sequence. Any questions so far? If I go too fast, let me know, put it in the chat, hop off mute, whatever. Anything's fine. We'll have a look at how that looks in an example. So in this case, dilate factor of 2 from the x-axis, you've got the square root graph. So 2 from the x means it's going in the y direction. It's going away from the x. So you multiply the y value by 2. Y dash becomes 2y. Rearrange, substitute. In this case, our function is square root x. Every x stays the same. every y gets y divided by 2, and then you just get the y back on its own. Any questions about that one?
Wait, so sir, with the y dash, with that part, why would we have to put the y on the left side and then the y dash on top?
Yep, because you want to take this and substitute it into your function. Your function has y and x in it. So the only way that you can do a substitution is if you have y or x on their own. And so for that reason, currently y does not exist on its own. It's got a multiplier of 2 on it. So to put it into here, you do your rearranging.
Oh, okay. Yep.
Sweet. Yeah, that's it. So this fundamental process applies to every transformation we look at. The other dilate is in the x direction. So it'll either say along the x or from the y. The books will always say from the y, but I have seen along the x occasionally. Exact same thing, but this time you multiply the x value. Exact same steps. There's no further rearrangement in this case though, because you've already got y on its own at the very end. This x divided by a after you do your rearranging doesn't need to have any further things done to it. So we look at how that looks in an example. Same dilate factor, this time it's from the y, so it's now affecting the x. Dilate factor is 2, so we multiply by 2. That gives us this, our x dash and our y dash. Get them in terms of x and y, which means rearranging these two, and then sub that once again back into our square root. So, fundamentally speaking, if you ever want to apply a dilate along the x or from the y, you always just take whatever's inside the brackets of your function and divide it by that factor. That's the shortcut at the end. Next up is reflections. So reflections will always look like a negative sign, either applied to the y value or to the x value, depending on what you have. Kind of like dilates, it's the opposite. So reflection in the y means the x gets the negative, whereas reflection in the x means the y gets the negative. And to highlight the reason why, I'll once again go to the handwritten section and draw a quick point on an axis, and we can see what that looks like. So, random point. If we're reflecting in the y-axis, it means that the y-axis acts like a mirror. And so if you imagine how a mirror would work, the image of it would be reflected on the other side of the mirror. And so when you consider what's going on here, pretend that's actually horizontal, you'll notice the x values have changed. This is a positive x, this is a negative x, but the y values have not changed. This is supposed to be horizontal, constant y value. So y value doesn't change, x value gets a negative. For that reason, any reflection in the y, where the y is the mirror, looks like this. You put a negative on the x. If you want to see how that looks like in the three-step framework, have a look back at the screen share. Again, you just put a negative on the x, rearrange, sub in. It gives you a bit more of an appreciation as to where it came from, basically. If we apply that to this example, basically you could go through those 3 steps just like before, or literally just replace each of these x's with a negative x. Either way is going to get you back to there. I'm going at a bit of a faster pace because we've covered this a fair few times, so if it's too fast for anyone new here, let me know and I'll go back and be a bit more detailed. Reflecting the x, exact same logic. So if we go back to the picture that I drew, reflecting in the x means now the x is the mirror, and so when you flip it down through the mirror, you'll notice the x value is constant, but these are 2 separate y values. Vertically speaking, it's different. And so under those circumstances, you get negative f of x. The negative goes on the outside because it's impacting the y value, not the x. Exact same thing on the screen share, except now, well, same function rather, but now we're just going to put a negative. Now, I like to put the negative literally on the y, because then when you do the rearranging, for whatever reason, it just seems a bit easier to know where or what things get negatived. Because if you just think about negative as putting a negative out the front, you might be tempted to just put a negative on the 2x squared. Whereas if you put it on the negative y, you know that when you do your rearranging, everything has to get hit by that negative. So that's a minor tactical thing I can recommend if you ever find yourself dropping negatives a lot. This might be a way of going about it. Put the negative literally on the y and then rearrange it afterwards. Last up for the fundamental transformations is the translation. This is where you're shifting either horizontally or vertically. These will look like a plus or a minus either on the x value or on the y value, depending on which direction you want to go. In the case of horizontal translations, you're applying it to the x, of course. Shifting horizontally, horizontal is x. X plus a shifts right, x minus a shifts left. Now, you might see in the function, things go opposite. When you're thinking about points shifting horizontally, it is the case that plus means right and minus means left, because you're literally getting a bigger x value. The reason why you've been conditioned up until this point to think x minus a is going to the right is because when you go through these 3 steps and you do your rearranging to get x on its own, when you put it in the function, it looks like a minus at this stage. But fundamentally speaking, when it came to just thinking about where the points were being shifted, it did start out as a plus. So in a way, you've kind of got to unlearn that a little bit if you do this approach where you think, oh, okay, cool. So it starts as a plus, then becomes a minus. Got it. So yeah, that explains a little bit as to why it looks like x minus a, when in reality you are in fact shifting right. So if we want to apply that in this circumstance, you can just use your function notation that you're already used to, which just means replace every x with x minus, well, in this case it's x plus 5 because you're shifting left, or you could do the point version, where you start with your x dash y dash, rearrange, and then sub in. If you know your function notation well, you basically skip these steps. But if it's a bit of a tougher thing for you, then following these will help you get to where you need to go on those. Any questions? Okay. Vertical translations, exact same thing. There is no strangeness necessarily around vertical translations. Plus is still up, minus is still down. The reason why the inversion doesn't seem to matter in this case is because when you add a to the y value and you do your flip to get y back on its own, when you sub this in, it goes on the left-hand side of the equation. And so there's actually 2 separate flips that occur when you're doing it in the case of the vertical translation, which is why you go from positive, negative, and then positive, and so it stays positive. So nothing crazy I have to remember from there. Vertical translations always look like a plus at the front of your function. So literally any function you ever come across that has a plus something at the front, as long as that something is a constant value, that is always considered a vertical translation. Like in this case, if you want to shift this thing down by 2, you put a minus 2 at the front of it. These are the same function with the exception of a minus 2 at the front. That's if you get your functions notation strong. Otherwise, these steps will help you get there. That's it for fundamentals. We'll look at how to apply them in a sequence of transformations, which is when you have to do multiple back-to-back. Any questions until then? Okay, so this is what we've been building up to, which is the reason why we would bother going through all this heavyweight stuff is because, in my opinion, it makes this stuff easier when you have to do a sequence in order. So we're just going to slightly modify the process that I've described, where fundamentally all you're doing is repeating that first step over and over again until you've filled out the entire list. So to highlight that, I have a sequence of 2 transformations here. They have the exact same factors, but they're written in a different order. You have to do them in order. So let's have a look at what that would look like. So the first is a dilation of 3 from the x. So we go from our initial xy to now x, 3y. It's going away from the x, which means it gets impacted on or gets applied to the y. Then where you start next is where you left off previously. So x comma 3y is our new starting point for the next transformation. So it's going to be a reflection in the x-axis, which looks like a negative sign on the y value. And lastly, you have to do the translations. So you can do those individually if you want, or you can do them back to back. Either way, it's shifting 5 in the positive x and 1 in the positive y. So you plus 5 on the x and you plus 1 on the y. This is your x dash, this is your y dash. So if you need to then apply that to a separate function, you just follow the steps as earlier, rearrange for x, rearrange for y, put them into the function. In the second example, this only really exists to highlight that the order ends up mattering. So let's pretend you did the translations first. That would mean you have a plus 5 and a plus 1 right off the get-go. Now when you do your reflections and dilations, it's not just the y value that gets the negative or the multiply, it's the entire thing in the y spot. So you have y plus 1 here, so the whole thing gets that negative. You have minus y plus 1 here, the whole thing gets that multiplied by 3. And so when you finally compare your two results, you'll notice this is definitely different to this. All that to say, the order matters. That's pretty much it there. So while I'll ask if there's any questions about that, and in the meantime, I'll do some screenshots of the steps that we have to follow regarding that. Any questions at all? Okay. So I have sent, you know what, I'll even just send it again. It'll be easier. So slight update to how we're going to do things here. What I've just done there is put in the chat a Word doc that's going to cover the particular questions that I think are unique in the textbook. So it'll break it down into what chapter sections we're doing and which ones are similar to each other. Like for example, 1A through C is similar to each other, D through E are similar to each other, all of 2, 3, and then 4, 5, 6, they're all similar to each other. All that is highlighted in that Word doc. And so instead of me trying to get everyone to do the exact same thing at the exact same time, you now have that in the chat, as well as a Google Drive that can download the book if you don't already have the book. The book is the Cambridge Unit 1 and 2 book. So you'll see a few textbooks on that Google Drive link. The one that we're looking at is the Cambridge Unit 1 and 2 book, chapters 7A through C. So that's what you can move on with if you're already quite familiar with the topic, and you can pick out the correct or the questions you want to have a practice on. And the other thing I thought was curious to give a shot would be doing breakout rooms. So instead of me just sort of going through the questions live and fielding for collaboration from you guys, I think it might be interesting to at least try putting everyone into a breakout room, and then I'll join each of those rooms individually and just sort of work through whatever question you're going through, and I'll continue hopping around until end of class. I think it'll be interesting to give it a shot, and then maybe at the end of the class you can let me know how that goes. Any objections to that? Cool. Okay. If it sucks, let me know. I'm more than happy to not do that. All right, let's give this a shot. Breakout rooms. Create. How many do we need? 1, 2, 3. Sign manually. Okay. That. 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 And that should do it. All right, you got an invite for that, I believe. Yeah, there we go. Sweet. Did you get that, Liam? Nice. Okay, here we go. Trial. rejoined. You have a question for me, or
Yeah, I can't seem to get in. To you do I can send it to me again? Like the join button?
yeah, I think I can just actually move you to it. Let me just do that right now.
Yeah.
Move to. Oh wait, no, I can't do that.
Okay.
You did join it, which is interesting.
Oh.
Um,
Oh. I thought I didn't.
yeah, maybe click. Have you still got the option to click the thing?
No.
No. Okay. Let me see if I can. All right, I'm gonna do two of them now. So click the second one that comes through. Move
Okay.
to ring two. Did it come through? Mm,
Yeah, I got back in.
got back in. Okay, doesn't matter. If you're the only one that's not in it, it's fine because we can just do it here. So
Okay.
whereabouts do you want to practice? Where are you up to?
Actually, I'm doing chapter 14.
Oh, sure. Okay.
Yeah.
Um, it'll probably be a bit tough if we're all doing completely different chapters.
Yeah.
Um,
But yeah, I could just do what everyone's doing.
yeah, okay. So is there anywhere in transformations you think would be worth brushing up on yourself?
Sorry. Sorry.
Is there anywhere within transformations that you feel like you want to brush up on?
Mm, yeah. Maybe I mean like I haven't started chapter 7 yet at
Sure.
school.
Okay. So we can maybe work on even on the first question, so we can get something going there. Okay. So question 1A. Let's give that a shot. So find the image of the point after mapping a translation. So I'll just write it down on the notes here. -3, 4. And we want to do a shift of 2 in the positive x and a shift of 3 in the negative y. So 2 in the positive x, 3 negative y. Any thoughts on how you might find where the new point goes?
Because it says like 2 units. Wait, what does it mean by like positive direction? Oh wait, going up?
Kind
Or
of. Up
oh,
and down, left and right will depend on if it's x or y.
okay, yeah. Okay, so 2 units positive direction of x-axis. That means it's like 2 units to the right and
Yes,
3 units down. Yeah, I know that.
that's it. So what do you think's going on?
Yes.
What do you think's the
Okay.
final point?
Mm, is it like -1 to 1?
-1 to 1. Yes, it is. That's it. So that'll help you out with 1A through C. D3 is going to be a little bit different. And then question 2 is slightly more different, but they're not too much different. So
Okay.
have a crack at trying those, and I'll jump out and help someone else now. All right,
Yeah. Okay. Thank you.
sweet. Hello, hello. How you been going?
Yeah, not bad, not bad.
Not bad. Okay. Whereabouts are you at?
I'm on 1B.
1B. All right. And
Oh,
how's that
one.
been going?
Yeah, good. Wanted to check if my first answer was right for 1A.
Yeah. What'd you get?
So what I did x dash equals -3 plus 2 equals -1.
Yep. Yep.
And then y dash would be 4 minus 3 to be equal 1.
Hmm.
So then the translation would be -1 and 1.
Yeah. -1 and 1 is correct. Absolutely, it is. Nice.
Oh, okay, okay. Yeah, that makes sense.
Yeah. So it's nothing too crazy at all.
Yeah.
Um, that one's just some addition subtraction stuff.
Hmm.
Um, how about yeah? I mean, you can do the rest of those if you want, but
Yeah, that's
how
pretty
about D?
chill.
D's slightly different because now you got to do or understand what it's talking about using the math terminology. So what do you think's going on there?
Okay, so so does that mean it is going 2 units in the negative direction?
Depends on what you're looking at. Are you looking at D or E?
E. So, oh, I'm sorry. I was looking at E.
Okay, well, if you're looking at E, then yeah, minus 2 units in the negative x is correct. Yeah.
Okay, so then the x dash would be -5,
X dash will be negative, yes, -5.
and then this one will be 3. So it'll be -5 and 3.
-5 and 3. Yes, absolutely. Cool. All right.
Okay, that makes sense. Yeah, cool.
Smashing it out. Very good. All right. So question 2 shouldn't be that much different to what you've just done. So
Yeah.
I'll leave you to have a go at a few of those for now, and I'll move on.
Okay, cool. Thank you.
Have fun. Hello, hello. How's it
Hello.
going?
Yeah, good.
Nice, nice. So, questions are chill enough, I'm assuming?
Yeah.
Yeah. Is there anything in particular you want me to have a look at from this?
Nothing so far.
Nothing so far. Cool. Whereabouts are you starting?
I'm on 2B.
2B for 7A?
Yeah.
Yeah. Okay. So you're just going to do them in order and have no. Yeah.
Yeah.
That's fair enough. Yeah. All right. Do you want to work through it together, or are you happy to just keep plotting along yourself?
I'm happy to do it myself.
Easy. All right. I'll leave you to it. Okay. We lost one. Let me just double check. Hey, hey.
Hello, sir.
Any luck so far with the new ones?
Yeah. I'm getting it. Yeah.
Getting it? Nice.
I think my question is like, why do we minus like for 2A to find the translation? Why do we -6 to -1?
-6 to -1.
Yeah.
Okay, no, fair enough. So I'm taking it you've like looked at the answers to try to figure out what was going on.
Yeah.
Yeah. Okay. Cool. So it'll be probably easier to think about them in terms of x dash and y dash, like
Yeah.
literally saying that x is -1, x dash is -6, and so
Yeah.
what would it take to go from -1 to -6?
we have to minus it.
Yeah, -5, right? If you minus 5, then that would get you there. And so when you describe the translation that gets you there, you would go 5 in
To the
in the
left.
left.
Yeah. Okay, so when you say with the x, x equals -1 and x dash equals -6, do we just solve for the x or no?
Okay, so if you're doing it that way, that's where it gets a bit more challenging because now you've got like a full equation that you're trying to solve, where you've got
Yeah.
transformations, like you would have like a whole ax plus b sort of situation going on.
Yeah.
Not quite. I mean, it is still doable. Like if you
Mhm.
assume that there's no dilations, because it does say literally do translations, then yeah, you could do -1 plus a, let's say, equals -6. And then when you rearrange for a, the translation factor, you're still going to get -5.
Right. So just to double check, with the translation, like you said, you described it, it's just a mirror, right?
Reflections are a mirror. Translation is just
Okay.
shifting. If you imagine like physically grabbing it and moving it left, right, up,
Oh,
down.
yeah.
Yeah.
I think, why would we have to move the graph?
Why do we have to move it? Like, as in,
Yeah, like
what would
why do we
this
have to
be useful
translate
for?
it? Yeah, what would be useful for, like, if you understand what I mean?
Yeah, no, I get you. So maybe to highlight this, I'll pull in the other camera, which I forgot is its own account, so I've got to assign it its own break room. Okay, let me pull that in. Assign to room 1. Join breakout room. Join. And it crashed. Huh. That's not great. Oh, hang on. Pick it up. Hey. There we go. Starting to see some holes in this idea where I have to pull cameras, but that's fine. We test things. Okay, cool. So cameras going in. What are the circumstances under which we would translate, or pretty much any transformation for that matter? One of the questions that comes to mind is one that came up in an application. Well, maybe you wouldn't call it an application question necessarily, but it was when we had some sort of function. Let's say it was like this on your axis, and this was some sort of, we had like f of x plus c going on, and what they said was figure out the value of c such that this only has one solution. This function only has one solution.
Right.
Do you know what I mean by one solution?
Yeah, it's like the when 2 points, like the gradient equal each other, something like that, right?
Something like that. Yeah.
Yeah.
So mathematically speaking, one solution simply just means your function, whatever it equals, so let's just say function equals 0 for whatever reason, it just means that you only get one answer at the end.
Yeah, right, okay.
That's it. So in the context of graphs, one solution just means touches only at one point.
Oh, right, okay, yeah.
This one cuts at 3. Now, specifically, we're talking about the x-axis in this case.
Yeah.
So what we're doing here is figuring out what must our vertical translation be such that we only touch at one point. Now, let's pretend this is the point 2, comma, -4, and this is the point -2, no, it doesn't really matter what it is, -2, comma, 3. If you imagine trying to shift this graph up or down so that it only touches once, what would you want to do?
For which one? That point?
Well, it's a good question. Because we just want it to touch once. I haven't said anything else other than the fact that we only want it to touch once.
Would you want to move it down to make it a straight line?
Make it down for a straight line. Yeah, okay. So how far down would you move it?
So you have to move, for the first point, you have to move it down 3.
Down 3, yeah.
Yeah.
a little bit more than 3 because you don't want it to touch at 0, but otherwise, yeah.
Oh, okay. Right.
So you would
alright.
say, so you could say that your C value would be less than, oh, sorry, yeah, because it's going to be a negative to go down. So C is less than 3. Less than -3, my bad. So anything less than -3, so -4, -5, anything like that, or even -3.000, whatever, will shift this thing all the way down because now it's going to look like that, basically.
Ah, yeah.
But that's not
So
the only way
that's
of
to
doing it.
find our C. Is that what you're saying?
Yeah, this was an application of transformations.
Okay.
It's not what we're doing here necessarily. This is like getting the fundamentals good. But this is where it's starting to lead up to, where you can start doing things like this.
Yeah. Okay.
Cool.
Mhm.
Yeah, like this is one that came to mind. There are others that are much more mathematically challenging. Like you'll have x comma y maps to ax plus b, comma cx plus d. They'll give you a bunch of information and they'll say figure out a, b, c, d, and that's where this like the exact stuff that we're doing here becomes applicable for solving that.
Okay.
But okay, so that's what one did we even do again? It was 3, 4. Oh right, we were doing 2a. Yeah, okay. Yeah, so to put like some words or written things to that, you would have -1 goes to -6. So you'd have -1 plus something is the same as the -6. And we know it's plus something or minus something because it's it's a translation. Translations are always plus or minuses. So when you do your rearranging, a equals -5, and so therefore your transformation is now x minus 5. That's your x dash. And if you were to describe that in English, you would just say, well, the words they use in the book is shifting in the negative x direction by 5, but we would know that it's just go left by 5.
Yeah.
Cool with that? All right. So you can try some of the question 2 if you like. Otherwise, question 3 is where you start applying these to functions. So that's where you're going to have to start using the screenshots in the chat where you've got the, well, maybe you remember it, but if you want to reference it, it's in the chat.
In the chat, sorry. So which one is it?
One of the screenshots. So I think the first
Oh, those
screenshot.
screenshots. Oh, yep. Sorry. Yeah.
Yeah.
Okay. Cool.
Sound cool?
Yeah. Thank you.
All right. Yeah, it's definitely not in it. Okay, cool. I thought it was my tech issue that dropped it. Okay, that's fine. Hey. Any issues so far?
No, not really.
No, traveling nicely. Very good.
Yeah.
Yeah. How about school overall? Has all that been pretty chill so far?
Yeah, not bad.
That's good. Yeah, no, for sure. Whereabouts are you at? So you're doing the calculus integration stuff, right?
Yes.
Yeah, yeah. And that's also been chill.
Yeah, it's been good so far.
Yeah. And I guess if this is a format that stays, then maybe one of the things, depending on where people are at, I mean, I can do stuff that isn't necessarily in the curriculum if you do want me to have a look at those. And it'll be a similar vibe with me just sort of pinging back and forth between where you guys are at. Um, so yeah, I'll even offer that. Is there anything you're doing currently you want me to have a look at, like in the in calculus stuff?
Um, there was this one thing which is like hard for me.
Yep.
I forgot what it was though.
Ooh, okay. Do you want to spend a second to have a look at it?
Yes.
Sure. All right. It'll be in the Unit 3-4 book, I'm assuming.
Yeah.
Yeah. Okay.
It's just like with questions that ask you to find like the minimum total shaded area and stuff, and like
Oh, minimizing shaded area. Okay.
yeah, and the maximum as well, which
Yeah.
confused me.
Yeah. Same thing. Okay. So it's the exact same process that you follow when it's like maximizing or minimizing area for quadratics. So do you remember how you do that?
Not really.
Not really. Okay. So when it came to doing quadratics, it was all about like finding a turning point. You would do your quadratic, like usually you'd have like a fenced off area. You'd have your perimeter thing. You'd have your area equation. You plot the area equation and you find the turning point of it. Is
Yeah.
this all ringing a bell? That's all ringing a bell, yeah?
Yeah. Yeah.
Yeah. And so we're going to do a very similar thing here, which is you still want to get it to a stage where you've figured out what your area equation is. Now you're going to be using integrals because now you're doing area of a curve, I'm assuming. And so the only thing is that your area equation is now just an integral. So do you remember whereabouts in the chapter you were doing?
This is from like a revision thing.
Chapter revision or your school revision?
School.
Oh, well, okay. Well, I can't necessarily pull a thing up for that. Let's see if I can find one. Maximizing area under a curve. I do know one. I do know one. I'll just have a look and see if there's one in here. Is there a picture for it? That's kind of it, but it's pretty deep in. Yes, okay. I'll pull up some notes that I have, and I think I've got an example of one. Okay. Calculus, apps, max or min. Pull up the screen share. Just realized I've got to re-up that whenever I join a room. Okay. Is it something like this?
Um, could I send a photo to you, like
Yeah, you can send a photo.
through the chat?
Yeah. Either that or maybe something like this.
Yeah, I guess so. Yeah.
Yeah, like this one. Okay, cool. So what's going on with this one here? Again, the goal is if you want to maximize the area of this, then the first thing you want to do is find an area equation, right? You need to have an equation which describes the thing you're trying to maximize. This is a triangle, so we start with our triangle equation. Area is half base height. all we're going to do now is start getting the terms correct. So what is our base? Well, it starts at -1, ends at x, therefore total distance, x plus 1. Cool so far?
Yeah.
Height, how are we going to do that? Well, starts at 0, ends at y. Height is therefore going to be y. But that's not super cool, because now you've got two unknowns again in your equation. And to graph it, you need to only have one. So we need to figure out a way to get y on its own. Or y in terms of x, sorry, I should say. That comes from the fact that this point exists on the semicircle, right? The semicircle is described by this, so the y value here is the y value that describes, or is described from here. So instead of saying h is y, we can now say h is root 1 minus x squared. Okay?
Yeah.
Cool. That gives us our area equation. You put in the thing for base, you put in the thing for height. Now, we have an equation which describes this area for any value of x. So if we choose a different value of x, it basically chooses where this is going to be. So this is like, let's say it's x equals a half, I think from memory. If you did x equals 1, it would be all the way here. If you did x equals 0, the line would be here instead. And so we're just trying to figure out where can I put this triangle to maximize that area. Maximums are always going to be at turning points, at least in a tech-free scenario. Tech-active, you might have to look at the graph physically to see where it's going to be. But tech-free, they're always going to give you a turning point in like so many cases. So we just try to find a turning point. Find derivative, set it equal to 0, and solve. That's a whole bunch of nastiness when it comes to tech-free. But are we fair enough on the overall steps there?
Yeah, it makes sense.
Do you want to dive in any deeper into what's going on? Into the arithmetic?
Not really.
Not really? Okay. Yeah, because it is just like getting u dash, v dash, those aren't so bad. It's just when you're multiplying it together and just doing some rearranging. That's going to give you two solutions, right? X equals -1, x equals a half. Which do you think, -1 or a half, is going to maximize this triangle? So basically, x equals -1 would put this spot here. X equals a half would put it, I don't know, let's say here. Where would you put it?
Half.
Half. Yeah, absolutely. This is where knowing the question is a bit easier, like seeing what's going on. You could literally just say, yep, okay, if I put x equals a half there, it's obviously going to make it bigger than if I put it here. There's like no triangle there. Now, if for whatever reason you don't get that and you don't see that, you can do double derivative stuff to figure it out, right? Like if you remember finding stationary points, you've got to figure out which one's min, which one's max. You can do double derivative, you can do sign diagrams, any of those.
Yep.
Sweet. So yeah, that's that. So this is the max or min problems document. It's under calculus, applications of calculus. Cool with that?
Yes, thank you.
Sweet. All right, I'll leave you to it. Hey, how you been going?
Yeah, not too bad. I'm starting to get it now. The application stuff.
Oh yeah, sure. Were you looking at some
Yeah.
application stuff?
Yeah, that well, questions 3, sorry, question 3.
Oh yes, putting it into the
Yeah.
function. Yeah.
Mhm.
So you're getting
Yeah.
you're getting them fairly well good.
Yeah. Yeah, I was getting the I was a bit confused on why we switch it, like when, like for example with number C, when we have to switch a 2 units to the negative to a positive. So I was a bit confused why that would happen.
Switching 2 units to a negative to a positive.
So
This
it'll be y equals f bracket x plus 2.
f bracket x plus 2. Yeah, okay. So to point out why that would be, oh, that's right, I've got to re-up the screen share. Let me grab that. Here we go. Okay. So the reason why it swaps is because you're doing step 2 here, which is rearrange in terms of x and y. So basically what it's going to look like if we're doing C is, I'll just write it out on the handwritten bit and we can have a look at it from there.
All right.
Okay, so we have f of x is equal to x squared, and then we have a shift 2 in the negative x and 3 in the negative y. So if you think about what your x dash y dash are going to be, what are we going to have for x dash y dash?
So it'll be -2.
Yep. So x dash is x minus 2, and y
And
dash
then
is
y -3.
y minus 3. Absolutely. That's the step 1 in that framework, which is identify the initial transformation.
Mm-hmm.
Step 2 is rearrange in terms of x and y. So if you want to get x and y on their own, what does that look like?
Oh, you have to move it. Yeah, okay.
There you go.
All right.
X dash equals x plus 2. Oh, sorry, other way around. What am I saying? X dash plus 2 equals x, and then y dash plus 3 equals y. And so now when you plug it into your f of x, remember f of x is just basically another word for y, you now write y plus 3 equals x plus 2 all squared, because you replace the x with the x plus 2.
Yep.
And then one final rearrangement, y equals x plus 2 all squared minus 3. Okay?
Ah, yeah.
Nice. All right, let's see you do it for another one. So if we do part D, D is so close to it's the same thing. Let's do E.
Yeah.
So E is going to be square root x as our function. What's our transformation?
So our x dash will be, our x, sorry, will be 2 units in positive. So it'll be x plus 2,
Yes, x plus 2.
and then our y dash will be 1 minus y.
1 minus y.
Or
y minus 1.
Yeah, y minus 1, yeah.
Yeah. So translations rather, are always applied as a plus or minus outside. If you put the negative on the y, what does that mean?
I'm actually not sure.
That's okay. It's in the second chapter, I think, which is reflections. All right. So when you put a negative on the x or on the y, it's a reflection on the.
Yeah, right. Yeah.
But okay, we got our x dash y dash. What do we do with it from here?
And then to rearrange it, it will be x dash minus 2 equals x.
X dash minus 2 equals x is correct.
And then for y would be y dash plus 1 equals y.
That's it. So.
And then it'll be y dash plus 1 equals x dash minus 2.
Square root x minus 2.
Square root, yeah.
And then, all I'll say is that we drop the dashes when you put it into the function, but yeah,
okay.
I know what you meant by that.
And then we solve for the y.
That's it.
Right?
Yeah.
And then it would just be square root x minus 2 plus 1.
Kind of.
Oh, minus 1, sorry. Minus 1, sorry.
Yeah, there you go. That's it. Smashing it. So yeah, that's final answer there. So that's the way that I find most people find helpful for it.
Yeah.
What I'll say is, and I'll just introduce it to you just in case you like this better for some reason, is doing this thing called doing it by recognition, which just means that you have a function. So we have our function f of x equals square root x. If the first thing is a shift right by 2, then what that means is you do f of x minus 2, right? That's a shift right by 2, if you remember from your function notation. So you go like that. Then the next thing, if it's a shift down by 1, you're doing f of x minus 1. And then that's going to go square root x minus 2 minus 1.
Yeah.
And so it gets you there slightly faster, but you just have to remember that you have to leave off or start where you left off. And the reason why this starts to kill people is because now when I say dilate by factor 3, what they do is they chuck a 3 on this, and they forget to chuck a 3 on this.
Oh, okay.
Because you got to multiply both of these by 3 when you multiply this, because this
Oh,
f
you're right.
is now this.
Yeah.
And everyone forgets it, and so that's why we do. Well, that's why I'm recommending that we do it this way with the x dash y dash stuff. But if you're, if you're crushing it and you can do it this way, then you can see this is much faster. Like, this is what? Got 1, 2, 3, 4 lines. This is 1, 2, 2 lines. This is just me adding stuff. Like, this is 2 lines. So, play it by what you know your strengths to be. If you're making careless mistakes, then stick with the x dash y dash stuff. If you're pretty solid with it, then the bio recognition stuff is good. Like Pia uses this stuff because she's crushing transformation. So this is a bit of a revision for her here.
Yeah.
But yeah, no, sweet. All right, I'll leave you to it. Curious to see what people thought of this. Feels like a lot of jumping around, at least on my end, that's for sure. Yeah, I'll be curious to see if people are like, yeah, no, I like the one-on-one afterwards. Or if they prefer me fielding the group for answers. Well, I suppose we'll find out. I'll just wait a moment for Joshua to make his way back. Ah, there we go. Yeah, so nearing the end of the session, I'll put a post out on school with a little like a poll to see if this was a kind of format you'd like to continue with. I know it's definitely a lot of jumping around on my end, so I don't know if that's looking disjointed to you guys or if you'd prefer the original thing. So I'll put a couple of options as to, do you like new thing, do you like old thing, or does something still need to change? If you have any final things you'd like me to clarify, I'll stick around for a little bit. Otherwise, I'll let you enjoy the rest of your days. Take care.
Hey, sir.
What's up?
I just wanted to ask you, what's it called? The Because I have a resit for my SAC, as I told you about it before.
Mhm.
So I have a resit, and it will be next week when I get back to school, and I don't know when and what day, but I just wanted to ask, like, what would you suggest me to do? Like on Jack Randall, it
Mhm.
covered chapters 1 through 5, and I already told the private tutor guy. So I
Yep.
just wanted to ask what's your insight on what I should do, like to prepare for the resit.
We should do well. The reset. I mean, you've done the test before, so you know,
Yeah, I've done the SAC
largely
before, yeah.
speaking, what's going to be on it. So if you can, you'll know better than me what kinds of questions seem like they
Hmm.
go on that test.
Yeah,
That's the kinds of things you want to do practice on.
yeah.
Now, we have plenty of resources here.
Hmm.
In fact, yeah, you've still got it unlocked because you joined early on.
Yeah,
Um, check out the practice act stuff. See
yeah.
if those are similar questions in there.
Hmm.
If not, I mean, the Jacaranda book, obviously, if it covers the Jacaranda stuff, then the Jacaranda book should have stuff in there.
Hmm.
Um, a lot of it's just going to be doing the repetitions there. I don't know enough
Yeah,
about your scenario to say whether you need to improve your test taking abilities or that
yeah.
sort of thing. But I
Hmm.
can say one thing that works well with a lot of people for test taking is
Hmm.
just go through the SAC, do all the easiest questions that you can do immediately, and
Hmm.
skip as soon as you come across any hardship. Like if you're doing
Yeah,
question one, part one's easy, part two's easy, part three I need to think about. Move on. Next question.
yeah.
Just
Okay.
get all the easiest marks as possible as soon as you
Hmm.
can, and then systematically work backwards from easiest to hardest, basically.
Yeah, okay.
I don't know if you
Yeah,
already
yeah.
do that. Do you?
Yeah, I do that. Yeah,
You do it?
yeah,
Yeah.
yeah.
Okay. Well, at least what I can say for now is that you have a solid test taking approach.
Mm,
Um, everything else is like really just got to be confidence in your ability, and that only really
yeah.
comes from doing a lot of practice questions.
Mm, mm,
So I can say, yeah, test taking strategy decently on point.
mm,
Your tutor now will be able to point you into a more targeted direction beyond that. But yeah, even before your class, have a look around, see what's in here,
mm.
if there's anything that you know is similar vibe.
Yeah.
Sound fair?
And yeah, one more question, if that's okay.
Yeah, yeah.
So, like, for me to just get better at like math, obviously you just have to do a lot more practice, right? And more exam questions.
Mhm.
And like, what do I do? Because like, say for example, with my friends, like they're not so easily accessible or able to reach out to ask for help.
Yeah.
And like obviously with YouTube and stuff, it's hard to like get that the exact answer you want because it just beats around the bush. Like, what do I do to like, especially if an exam question is I'm struggling to answer, what do I do to
You ask
like
your
for
tutor.
that?
You ask your tutor, or you ask you. Oh, you ask me because both programs give you access to tutors. Because you're in the
Okay.
group and the private. I don't know if I made
Yeah.
it clear enough, but you can
Yeah.
text us after hours with any questions that you have. Like,
Mm.
because as you identified, the way to get good at doing methods is doing a lot of practice questions.
Yeah. Yeah.
And where you're probably wasting a lot of time is doing that trial and error over and over again on the questions and not
Mm.
realizing that there's just, you could just get a direct answer from your from an expert and be like, oh
Yeah.
no, do
Fair.
it these ways.
Yeah.
And so yeah, if you come across those questions where you know you can get well, if you think it's going to be reasonable enough to get a quick answer to your question, then give it a shot. If it's
Hmm.
starting to feel like you would need a video or something like that,
Yeah.
then that's where it starts getting a bit more tougher. Like if you need to have
Yeah.
someone hop on call for a couple of seconds or a minute,
Hmm.
that'll be up to whether your tutor's going to set that boundary or not.
Yeah.
But in the meantime, if he does set that boundary, then you've got my video resources and my written resources, which cover,
Hmm.
I'd say they cover like a solid 70% of everything you'll come across.
Yeah. Okay.
It's all the key questions. There's going to be obviously
Hmm.
some that are like stranger for sure, but
Yeah.
everything key. I would say that if you get expert at everything that I've got here, you'll get
Hmm.
a guaranteed 70% on what you do.
Okay.
And,
Cool.
that's obviously tough to say because expert, right?
Yeah. Yeah.
But all that to say is I think that I've covered a solid portion of what comes up because there's always
Yeah.
going to be
Hmm.
novel stuff, but
Hmm.
a lot of method stuff is recycled. in the test.
Yeah. Yeah.
Sound fair?
Yeah. Thank
Alright,
you very much.
Yeah.
I
So we
appreciate it.
support you as much as you can, right? So
Yeah.
just reach out. That's a big part of this.
Yeah. Okay. Cool.
All right. I'll
Thank
leave
you
it to
very
it.
much. Have a
Take
good
care.
day.
You as well.